Okay, so let's have a chat about cubic functions. So you've been working on quadratics, you've been working on polynomials. You may not know what a cubic looks like, but probably you've seen one before. So a cubic typically is going to look a little bit like this, and there's a few things we need to talk about. So firstly, the form of a cubic is y equals ax cubed plus bx squared plus cx plus d. And it's going to look a little bit like this. It goes on forever, but now the pattern is set. This one goes on forever to infinity, this one goes up to, so down to negative infinity, up to positive infinity. There's a couple of features here though. See this d, that's just a number. It's going to set some parameters, and in amongst here where it's a little bit sort of clumped together, it's going to be really important. The c, that's just a linear thing, so it's some number times x, whatever the value of x is. The c x squared is pretty powerful because now you're squaring a number, so it's getting bigger quicker. But the x cubed has all the power here. So in this centre part, they all sort of play an equal role, and they all have really important features. But overall, once you get out to the extremities, it's a cube that takes the power. Let's say, for example, we're looking at negative 10. Yeah, negative 10 cubed is negative 1,000, whereas negative 10 squared is 100. So you can see the difference there in the power that this term has over the whole function, which is why we get this, it drifts off. Irrespective of what everything here does, the cubic makes it drift off in these two directions. Now the feature we have here is that this is what the cubic will look like if a is positive, because then when we do the negative value cubed, we get a really big negative, and then a will affect it in terms of a dilation, but ultimately it's going to follow this shape depending on our scale. So we're going to end up down here in the negatives. The alternate one, which I'll do in as different a colour as I can, and we'll throw it in blue here, is that if a is negative, it means that we're going to reverse the function. It flips it over. And we end up coming from the positives. We still get this little sort of swing around somewhere, and then it goes down to the negatives. Okay, now we all know there's some translations that take place. The whole thing might be moved this way or this way, up or down. But the general shape is that there's some stuff going on in the middle, maybe with a couple of humps, and then we get these outskirts, and it all depends a little bit on the value of a. So that's what the cubic looks like. What we're going to talk about now is how we might sketch a cubic, and we'll do an example of that. Okay, so we've got a cubic here, and we're going to look at sketching that cubic. But first, we need to talk about how we would sketch it. So if I draw my little axes over here, I'm going to use this axis to sketch my cubic. I know the general shape, and we have two options for sketching it. We can do it either through important values, key points, and then using the shape, or we could do it by considering transformations. Now for this one we're going to use the key values. We'll talk about transformations in the next video. So the key values here are, the main ones we've learnt about, the y-intercept and the x-intercepts. So remember, this is a cubic, so there might be up to 3 x-intercepts, but there might only be 2 or there might be 1. Okay, now it doesn't have to start low and finish high, or start high and finish low, so there has to be at least 1. But there might only be 1. There might be 2 in a special case, which I'll talk about a bit later. So for now, let's have a look at this cubic and how we sketch it. Now I can see the y-intercept. Remember, the y-intercept is when x equals 0, I get y equals 0 plus 0 plus 0 minus 30. So y equals negative 30. I can plot that down here. This may be important to me a little bit later on. We'll start with a negative 30. Now what I'm going to do is find my x-intercepts, which occur when y equals 0. And then I get 2x cubed plus 11x squared minus x minus 30 equals 0. Now, I'm just going to go through this pretty quickly because we don't have repeat processes here, but imagine in previous lessons you've looked at polynomial division factorization for cubics. So imagine here that I told you, well, x plus 2 is a root. So I've tested negative 2 in here, and I get negative 16 plus 44 minus plus 2 minus 30, and it works out that that gives us 0. So x plus 2 is a factor. So I get x plus 2 multiplied by something equals 0. Now I know, and I'm going to use my equating coefficient, this is 2x squared. 2 times what equals negative 30, that's negative 15. And I'm looking for this middle term. How am I going to get this 11x squared? I'm going to get it by something times the x, and then plus 4x, so this must be plus 7x. And then that gives me plus 4x squared plus 7x squared, 11x squared. And then I can factorise this next one by doing x plus 2, and I get 2x and x. This is just me showing my thinking. I know 2x and x is the only way to make 2x squared. Assuming I've got this, I can factorise it, of course. If I can't, maybe they're irrational numbers or fractions or something. I've probably got a negative 3 and a negative 15, and I can see here, if that's a negative 3, I get negative 3x. This is a plus 5, I get 10x, and that gives me my 7. So there's my factorised version, and when I solve this, I get x is equal to negative 2, negative 5, and 3 over 2. So I'm going to plot those on here. Negative 5, negative 2, and 3 over 2. And then I've got this guy down here as well. So that tells me that it goes down there. It's going to be a little bit beyond, probably. It's up, down, and this will continue on up here like that. And that's my cubic. Now this is all the important information we've got, as well as the shape. I don't think my turning point is going to be here on the y-intercept. It might be, and we haven't really gone in far enough into calculus to work that out yet. But it's not really the split difference of those. It won't necessarily be, but it's going to be pretty close to that. So I'm not going to deliberately mark that as my turning point in the y-intercept, but I'm going to mark my key points. And I've marked all my key points there. They're my intercepts. And in this case, there are 4. I've got the clear turnaround points. I've got arrows in the end. It's a good representation of my cubic. And so that's how you draw a cubic using key values. If you're lucky, you might have some information here about your turning points, because that's the next set of key values. And later on, in term 3 of this year, we'll start looking at things called points of inception. Points of inflection, sorry. So we'll get to that. Anyway, a couple other things you might consider. First of all, is something called a sine diagram. So we could have a play around with this original value here, particularly if we've got these x-intercepts. We could have a think about, well, what's going on in terms of the value of y. So my y value here, well, it's negative there, and then I've got an x-intercept and it becomes positive, and then I've got an x-intercept and it becomes negative again, and then I've got an x-intercept and it's positive again. A sine diagram here, something like that, gives you a bit of an indication of what's going on. It's in a way we can think about it as well. What I want to do now is just show you, it'll take about a minute. After this, I'm going to rub this off. We're going to have a look at double roots and what they might do to create a situation where we've got 2 intercepts instead of 3 or 1. Okay, so we've got another function up here, y equals x minus 2 squared times x plus 3. It is a cubic, it's just in this case we have a double root. So if I expand this out, I've got x minus 2, x minus 2, x plus 3. So we can see our 3 factors, we can see the cubic nature of this function. But we have a double root, so that's what we're dealing with. And the double root is x minus 2. So we actually have the y-intercept is going to be equal to, when I expand this out, my constant term will be 12, and my x-intercepts will be 2 and negative 3. But 2 is a double root. So let me just mark this on here. There's negative 3, and there's 2, and my y-intercept is 12. Now what a double root means is that it goes down to 2, it touches, and then it sort of bounces back off. So it actually means that the x-intercept is also that turnaround point, which we call a turning point or a stationary point. We'll get to a bit later. And I know that this is my y-intercept, so I know it must come down from the y-intercept and turn around and head back up. And of course this then goes like that, and there we've got our normal cubic. 2 x-intercepts, 1, 2, but this one is a bit special. We hit it, we go down, we hit it, and we come back up. So that's a bit of a special type of cubic, and you see where it comes from here with our roots. Okay, well thanks for watching this video. Next video we'll have a look at transformations to draw cubics.